And yeah, in just a second, Mitchell, feel free to share your screen and start presenting.
All righty, perfect.
Okay, should be good to go.
Perfect. And if I get done acknowledging all of the things, we should be good. All right, with a little bit of luck, I hope. Do you guys see the slideshow?
Yep.
Perfect. All righty, so thank you very much. Appreciate the introduction and glad to have everybody here this evening. As previously mentioned, please do feel free to get any questions that you may have in the chat throughout this. Welcome any questions and conversation along the way. So don't hesitate to reach out. My contact information is also here. I'll put it back up at the end as well, just to make sure that everybody has it. If you have questions about anything that I talk about today or any of the samples or anything I show you, please don't hesitate to reach out. This topic, as well as any of the other topics that I talk about, as mentioned in my intro, I really like sharing the information with others and helping to avoid things getting out of hand or being implemented in an incorrect manner. So please do reach out if you have any questions at all. So I want to start out a little bit with just why login. Why do I think it's a topic of discussion? What are some of the reasons that this has bubbled up into something that's been more popular? And the easiest way for me to look at it is it's one of the most common forgotten things within application development. We have log messages, we write log messages, we may even look at them, but we don't necessarily think about it. We don't talk about it. We don't talk about it as part of the regular day-to-day development process. Although it is impacted or reflected in two different areas on the OWASP top 10 list of security vulnerabilities. Broken access control and insufficient logging and monitoring are two of the items on the top 10 directly related to things related to login. Broken access control can be anything from allowing somebody to do something that they shouldn't be able to do, but the login tied to it is I should know when somebody did something or who it was that they did, or if they were doing something critical. I mean, then insufficient logging and monitoring is literally a blanket statement talking about the fact that you may not monitor the logs. So you may not be tracking something that you should be tracking, or if you are tracking it, you're not looking at it. And with all of this, though, there's so many ways to do it, but there's not a do it this way. The recommendations, the goals, the things that Microsoft puts out, the default file new project experience, all of those things provide pieces to the puzzle, but they don't provide the full comprehensive puzzle. So we don't really have a great, just do it this way. So it makes things really a little bit difficult to get a good understanding. And the out of the box recommendations in those samples leaves questions. Doesn't really work, doesn't do what people would expect it to do. And there's no, oh gosh, go over here and you can accomplish the goals, or this is what makes sense from a regular development environment. So I always like to start out, although we're virtual, with a couple of questions just to be thinking about as we go through things today. First and foremost, are you actively including logging in your code today? And in this case, I'm talking very specifically about logging that you may do as a developer. So are you writing out log messages to identify critical path items or situations where there's an error that's been encountered by a user or privileged access being used? Any of those kinds of things, right? Are you taking care of those today? Then, assuming that your answer is that you have some sort of logging in your code today, and this may be something you write, it may be simply IIS logs, it may be any combination therein. Do you have an escalation process for those logging events? If it's just IIS logs, do you have anything to review to try to identify, have you been a victim of a denial of service attack? Do you have malicious users trying to crawl your content? Those kinds of things. Do you have any process that's documented for escalating those? And then lastly, do you look at your logs on a regular basis? And I understand how silly of a question this may be, but one of the most common things that I see when I step into a new environment to go look at something for somebody or to help them diagnose an issue is a situation where there's a log platform that is unkempt or hasn't had any type of interaction with a human being since the last time something went horribly wrong. So it's not uncommon for me to go in and see a log event that simply says, hey, we've got 3 years of log files. Well, I'm guessing that that's not a great idea. And we'll talk a little bit about why that might be a really big idea, big problem as we get a little bit further in. So what am I trying to get today? What do I want you to be able to leave this session with an understanding of? And I want you to understand what logging can do or not do for your organization. I think as much as we talk about logging and we start to integrate it and make it part of a process, we need to also understand what we shouldn't be doing with it. I'm going to talk a little bit about escalation protocols. How do we actually go about escalating? What makes sense from an escalation perspective? And related to that, I'm going to talk about sensitivity of those escalations. How do we do things to escalate and elevate our logs to become actionable, but to do so in a manner that doesn't overwhelm our development teams, that doesn't get people doing things to actively ignore our messaging. And then we're going to talk about logging in .NET Core, which is obviously what we're really here for. And we're going to talk about the specifics with a bunch of code examples. All of the code samples that I have are in a GitHub repository. I'll walk through some of it tonight, but it's also just an application that you can download. It has the slides and everything from this presentation in it. And the idea behind it is to give you a turnkey, here's how you can configure logging in ASP.NET Core, or you can even do it in console apps or other apps as well. But here's how you configure it to do the things that we're talking about. And then you can do whatever you need to do with it afterwards. So the real goal here is to make sure you have some solid examples to be able to get things accomplished. So when we talk about logging, why would we want to use it? What are some of the things that we can do with logging for our business and to aid us as developers? Well, the most common thing that we think of is to log diagnostic information, debug style messages, those kinds of things where we're trying to figure out why did something not work right. Oftentimes, you'll think about this being used in lower level environments. You'll think about that in your development or your testing environments where you log out things that, you know what, maybe this shouldn't happen, but I want to make sure that I have the information. Areas that people don't necessarily think as much about, though, are audit information, things where we're tracking or documenting things that users are doing. If we look at the OWASP list and broken access control, what they're talking about with access control isn't only did I accidentally give you access to something that you shouldn't have, but we're also talking about making sure that we have audit trails to know when you access something. So if I log into the system and I go in and I click a big red button that says delete all of the things, there should be appropriate audit information that shows that I logged in, that I did this particular action, especially if it's a destructive action or something where we're resulting in data being removed or anything of that nature. We also could think about it for those other general critical path items, accessing certain configuration settings or decrypting things that you maybe don't necessarily, do on a regular basis. Another good one is credit card transaction logging. A great way to think about that is we don't want to log, obviously, the credit card number, but we want to log certain information about that credit card transaction. Maybe we log how they got there. We get an IP address, a date and a time, and a transaction ID, so that later on we can mash all of that information together. A great out of the box idea of looking at like what kinds of things should we be logging is to take a look at what ASP.NET Identity does for user accounts. And users that attempt to log in to a user account with an invalid password, users that hit a lockout or aren't able to get into their accounts, those are things that Microsoft is already writing to the log stream that we can listen to. So anything here that we can do to be able to audit or follow the progression or do things to support our application become those kinds of critical elements that we really should be including. And then lastly, we have exception reporting. This would be the ability to simply say, hey, I know the application had an issue, and I'm going to go ahead and start looking at it before the users are reaching out to me. By combining exception reporting with audit information as well as diagnostics, it's very possible for us to be able to paint an entire picture. Yes, this error happened at 6:50 p.m., but at 6:47 p.m., the user had logged in, they clicked on this, and then they got this error message. So we can combine our overall log information with the different types of logs to be able to paint a picture and understand what's going on in our applications. Now, obviously, that sounds like a great idea, but we have to make sure that we take care of the information security or the sensitivity of the types of information that we are logging. Now, when we talk about sensitivity with information or security of logging, we're not just talking about what I put in the logs. We're talking about the physical security of the logs. Who has access to actually get to the log files? So in other words, we don't want to be writing all of our log files, for example, to a text file that can be served via IIS to anybody that's visiting our site. We don't want to drop them to a shared network location that everybody can get access to. We also want to look at retention. The longer that we retain the logs, the more we could potentially be having a security concern for us as well. We need to keep our logs long enough so that we can do things, but we need to adjust that retention to be able to balance everything that we're working with. We then also need to look at the information we're included. Rather than logging the name of the user and putting that PII all over the place, why don't we log a unique identifier or something so we can go back and find the information so we can assemble it later? Don't ever log a credit card number, that kind of thing. And all of this, physical security, retention, included information, it's a fine line. Every single organization is going to be different. You're going to be balancing enough information to be able to recreate the issue or enough information to be able to document what that user experienced, why they experienced something, and not having too much information to violate privacy concerns or security considerations. For those of you that are working with organizations that do international business, GDPR and some of the data privacy things does add some additional concerns. GDPR puts, for example, a little bit more restriction on when you should be able or should be tracking things such as IP address. So being aware of what is specific to your entity is going to really help define some of these retention policies or other security aspects. E-commerce sites, I always like to use them as a good example. E-commerce transactions with the credit card companies, right, are things that can be disputed typically for up to 60 days. So anybody that's running an e-commerce solution that doesn't retain their logs and for at least 65 days or so is crazy. Because if we know that a person can dispute a transaction for a certain amount of time, we absolutely need to have data for at least that long and give ourselves a little bit of wiggle room just in case somebody tries to do something right outside of that window. But again, your individual organization needs are going to define this a little bit more, as well as regulatory or other governance. Now, we're talking about the severity and the security of what we're tracking, we need to do something with it. We need to tell somebody, we need to escalate, but how and who? Taking your login information and actually putting it in the best location is critical for you to be able to get that information and be effective and ensure that your systems are being used appropriately. Any extremes with visibility or notification of escalation is going to reduce the effectiveness of any implementation that you put in place. So for example, we had a client that had a logging system that documented every single 404 that was encountered on the website. Now, I'm not talking about every single unique 404. I'm saying anytime a 404 response was returned, that system, they're like, it has to email. Well, it did. Filters got created and logs got ignored within hours of the site launching. And the idea behind it was, well, we want to be able to know because we did a migration and we need to be able to do something. Well, that's great, but so many things happened that folks just ended up creating filters, pushed that information off to the side, and they never looked at the logs again. So now we have a completely ineffective solution. So just one example of by going too forceful with those notifications, we effectively render our logging useless. And it's something that we want to take a look at. Now, the bigger question is often, well, how do I do this? How do I take these login messages that are there in .NET and do something with them? Out of the box, and this is part of the reason why we have such confusion, we have support console, which is what we experience as developers every day, right? We see it in the console or debug. We have application insights and event source as two other destinations. So application insights is actually a fairly good place to put things, but not everybody is in Azure. Not everybody has application insights. Not everybody wants to push everything to App Insights. App Insights is great for certain things. For example, it's a really good place to store errors or warning style information where you have less frequent items. I don't know that tracking every single debug message into application insights is probably the greatest idea. You pay by ingestion, etc. Probably still isn't the best location. So, well, where do we go from here? Well, we have third-party options. And in the third-party space, we have an unlimited collection of things where we can go to files, we can go to email, we can go to Azure Storage, we can go to other logging tools like exceptionless or SEQ. And all of these destinations have their own pros and cons. And the idea here is that we want to get to a place where we can take those default things and push to all of these other things so that way you can compose a escalation protocol that is based on the severity and nature of the message and as well as the specifics of your organization. So as I go through things tonight, I'm going to be talking about open source options to be able to take those log messages and get them elsewhere. The stuff that I'm going to be talking about in that regard is a collection of things known as Serilog. It is open source, it's free to use. There is a commercial product that is managed by the maker of Serilog called SEQ. And SEQ is a final destination for log entries that allows you to do some of those escalation pieces. It can handle emailing you of new errors. It can give you analytical reporting of your log files, etc. It's totally optional. You can use any other tool that you may want as well. Just so happens to be that it's a great way to support a really well constructed open source contribution, but it's also a way to accomplish a business need with a product that's at a fair price. So by all means, look at your own stuff, but that's why we're kind of walking down the road that we are here tonight. Now, when we talk about different escalations, by different severities. What do I see? What do we normally see an application or a customer wanting to do? We typically see a dual configuration splitting on severity for how we do login. If we look at most of our applications, errors are something that people want to do something about, and they want to do something about it quickly. So errors are typically, we log them locally to the file system because we still want to have history of them with any other error messages that we may have. But we want to send those to an external service for aggregation purposes. So in this case, I don't want my application taking the responsibility of, oh gosh, we encountered an error, send an email. I want the application focused on doing the applications thing, and I want it just taking those error messages and getting them off to somewhere else, right? We don't need to bog down our application by doing more things with logging or more things with notifications, because it's just more things that can go wrong. It's more resources utilized by our server at any given time. And then everything else, we simply log it to the local file system and we keep a history of however long. Default's a 30-day rolling history. Most of our clients, 30 days is a great history time frame for logging. If you're e-commerce, I definitely recommend you bumping that up to at least 60 days. And depending on your other, whatever other organization types you may have, right? Some banking and finance customers, for example, like to utilize 2 years as a retention period. Use your best judgment here. But what we then do with this is by pushing to an external service, the alert thresholds get managed by an outside party. So in my case, right, we ship these to SEQ, and where we get some real value here is the application does the same thing every single time it gets an error. It sends it to that outside party. That outside party is then responsible for doing any type of alert threshold management. If you want to only send one error message email every 10 minutes, let that external service handle that. Let your application just do its job and notify you of things. It's even better if you can do online adjustments to login levels. Just so happens that SEQ has an ability to dynamically reconfigure login level without an app restart remotely from their login system, which is a huge value add when you're trying to be able to do things. And the idea is I always want to have quick access to my detailed log messages. So I want to make sure that whatever escalation process I come up with, I have a way to get all of this information out. So now let's talk a little bit about the unique aspects of .NET login for a moment. As we mentioned a little bit before, the default configuration logs messages to the console and debug. It's on by default, but almost every developer doesn't look at it, right? We've talked about output targets being limited. I know most of you have probably looked at your app settings.json and you see this login section. So many people just leave the login configuration in their app settings JSON and they don't even know what it does. So it's something that's there. It's something we don't know what's going on. There is then a concept of understanding what logging does at a high level. And inside .NET Core or .NET 6, anything, whatever name you want to call it by, there is a logging stream or an iLogger interface, right, that you can utilize. And it is a single logging stream for everything that allows you to filter by type, category, and namespace. And the idea behind this is it allows us to get access to all kinds of information. Since it's one stream, it means that ASP.NET is writing its logs to the same place as your application is writing its logs to, which is the same place that Entity Framework is writing its logs to, which is the same place that Kestrel is writing any of its log entries to. And the idea here is that we can get access to it and we can go through and do a bunch of things with that. Third-party support obviously is where we get into the real fun stuff, but what can we do with this combined log stream? What does it allow us to see of Microsoft's or of entity frameworks that we don't necessarily see or care about? Well, we get to a place where we can utilize the logging to expose bottlenecks or optimizations. Two of my favorite examples are that Entity Framework Core, anytime your model is initialized, it logs out any optimizations as warnings or things that it thinks you should have done with your model. A great example is a decimal model field that doesn't have a precision and scale defined. You can go through and build your code. It won't have any warnings. You can create a migration. It won't have any warnings. You can apply the migrations. You're not going to have any warnings. But every single time your application starts, each individual decimal property that doesn't have a precision and scale is going to write out a warning message. So it's a great way to look at what Entity Framework is doing. You can also use it to log out diagnostic data, especially on the Entity Framework side of things. With one simple log level configuration, we can tell Entity Framework, I want you to spit out every single query as you're executing. I want you to tell me how much time it took for you to execute that query. And then we can get full breadcrumbs for traffic patterns as well. So let's just say you're doing some customizations to routing and you need to be able to get an understanding of why didn't your controller get called or why did this controller get called. You can actually tell an .NET Core to include all of that information about how it decided to respond to your specific set of requests. So, when we look at all of this, what kinds of things can we get? What kinds of information is typically included in these? I just wanted to include a couple examples of an escalation or an email. Like this is one that came out of SEQ in our case. So you can see here we have a lot of actionable data. This is the method that happened. This is the error. This is how much time it took. Source information, that kind of thing. This is a view of log entries utilizing the SEQ product. Again, there's other tools and mechanisms out here, but the idea is I've got a searchable interface now. I can go and find things. I can see here that certain users weren't able to log in successfully. And then I can dig in even further. I can see that it came from a particular application. I can see that it was from identity, that kind of thing. And all of these kinds of things make it easier for me to be able to understand what's going on. You can see here at the bottom, I've injected the user ID. So user ID 1340 is there with that log entry. And the idea here is that if we combine logging in a structured fashion with a tool that can work with structured logging, then we can get ourselves into a place where we can truly take action on our log entries without having to do a bunch of extra effort. And to this point, one of the more common things to make sure that folks understand is the proper way to output log messages. So this is a way to output a particular log message. We can use _logger as a reference to an iLogger. We can log information, and then what we do is we provide a message template, and then we provide any parameters necessary to that template. Now, if you notice here, it looks like an interpolated string, but it's not. I don't have the $sign beforehand, and this is really, really important. The key here is I'm simply saying this log message is user information, and then the user's info is here, or request in this case. And what this is going to do is it's going to output the information by simply calling ToString. So this is fairly safe. Obviously, this isn't a very helpful log message with the way that it comes out, but it's a protected log message, right? We're not doing anything that is bad from a user perspective. Now, if I change my message template to include an @ sign, that is going to indicate to the system that it should attempt to dump the object rather than calling simply ToString on it. That is going to result in the entire context of that object being written to your log entries. And as you can see here, obviously I've shortened this a little bit, but anything and everything for that object is going to be included in your logs. So as we start to look at logging and you look at where you're going in your message formats, this is something where making sure that you understand what those templates are and what information might be included becomes critical. Third-party tools such as Sonar Cloud or SonarQube to do static code analysis, oftentimes they will have alerts or warnings that will catch these kinds of anti-patterns to try to tell you that, hey, this may be some unsafe login information. But it's still part of the developer experience to really make sure, especially during your code reviews, that you're cautious with anything that's used to dump information rather than simply outputting that information to the user context. So a few resource links I'll put up here for just a second, and then I'll dive into the code sample here. And if we have any questions, I don't see anything in chat yet, but I'll kind of walk through a few things from an application perspective. But the GitHub repository, that's a link to the sample that I'm about to show you guys, as well as these slides. EF Core login details, and it's just a direct link to all of the login configuration elements that exist for EF Core. It's really nice, a handy way to be able to understand, like, oh, if I turn this on or this off, I'll be able to see this information. It's really hard. A lot of people, read some of the older documentation that you have to do a bunch of things to trick Entity Framework into logging out queries. Yeah, you don't have to do any of that in anything .NET Core. Some information on Serilog out there with a bunch of the different Serilog packages, as well as there's a link to SEQ, which I mentioned is that structured logging reporting tool that works in conjunction with Serilog, but it can work with other things as well. So without further ado, let me get into the code samples. And the way that I structured the code samples to make life easier for everyone here is it is a standard ASP.NET application. I utilized the out-of-the-box template, so I didn't make any real changes to the default template, other than the fact that I added in the home controller a number of actions that just do some basic output messages so that you can see what they look like and you can actually generate log messages within your individual code. So assuming that everything is configured for login and we have it all working, it's nothing more than injecting an iLogger of your particular type, which is handled by dependency injection for you. And then anywhere that you need to do an output, you can do logger.log warning, logger.log information, logger.log error as you get down here. So this becomes easy for you to be able to implement these within your application. At the end of the day, the log messages and formats that we get will become very structured. You can see here that I've got some more detailed information, where this is where we're looking at some of the Microsoft bits, but nothing more than a note of each of the individual methods that may have been completed. So if I start and run the application, just so you can kind of see the most recent updates and log messages, with a default configuration, I should be able to kind of step through. Application will start. I can click through to trigger a warning, look at some other documentation. And you can see here that what I did with this is try to give you as much information as I can. Here's how you can trigger some complex logging, good and bad style. Here's what the bad process looks like. Talk a little bit about the security and privacy considerations. This is a more detailed example of dumping the request object rather than dumping like user identity. It ends up being like 4.5 megabytes of data that gets dumped if you do that to the request object. And then for EF Core, I have some links that show you exactly where you can go to do that kind of stuff. I also have identity still in here. So As long as you update the configuration file to point to a valid database with a valid database user, you'll be able to, see what entity framework log messages and things look like. So if I go back and look at my log file, you'll see here that if I scroll all the way down to the bottom, looking at 1713. So we can see here that, I've got a message here that says we are starting the web host. Oh, user profile is available using users owner app data local data protection key as a key repository for and Windows DPAPI to encrypt keys at rest. Well, gosh, that's a message right out of Microsoft. It's really nice for you to kind of know what your application is doing. And then you can see here, each of these log entries, we have a correlation ID added to these log entries, which I'll show how to do in just a second. But I know that this is one web request. So this was me looking to load the homepage. And you can see here that these are all of the Microsoft log entries that tell you at an informational level what was going on. And so I've got it by default set to this information level so you can see exactly what Microsoft is able to tell us at that most basic level. And you can see here that a request was started using HTTP2 for a get of this address. We're executing this endpoint. We matched the route with this information. Now we're executing this action method. We executed this action method. Now we're executing the view result and we're running the view with this name. We executed the view result with the view and it took this much time. We executed this action, which is ending what we started in this much time. And then we executed the endpoint and here is our total response time. So the idea here is we get a lot of access. And if you see here, notice how I see things like request started for jQuery, jQuery UI, site CSS, etc. Okay, well, that's all interesting stuff. So how do we get all of that configuration? How do we manage it? Inside of our app settings, we have a new configuration section called Serilog. This is the easiest way to set things up with Serilog. You can do it other ways, but using the JSON configuration is so much easier because you can then control this in your build process or otherwise. But we set up a Serilog section. We tell Serilog what things we want to use. Inside of Serilog, the concept of writing a log entry to a specific location is known as a sync. So a sync of console is writing to the console, a sync of file is writing to a file. So we can see here that we're just telling it we're going to use the console and the file system. We then have minimum level configurations. And this is one of the pieces that I always like to just explain to folks. And that is that the default level for minimum level sets the barrier to entry for any and all log entries. Whatever this is set to, every other configuration has to be that level or more severe. In other words, if it's debug, you can set anything anywhere else because it's debug information warning error. But if I set this default to be warning, nowhere in this configuration are you going to be able to get access to information messages. So typically speaking, I like to limit things down to, say, debug, and then let the other filters control what's going on. Then you see the next line down, we establish a number of overrides. And in this case, we have overrides where we say Microsoft, we want anything that starts with the namespace of Microsoft, we want to be information. Anything that starts with a namespace of system, we want to show warnings. Anything that is Microsoft Entity Framework Core Database Command, we want information. And what that does for us is for an entity framework query, that actually will log out each individual command that's executed. So you can see here, executed DB command in 2 milliseconds, a parameter of normalized username. The query was select top one with this from ASP.NET users where normalized username equals that parameter. Notice that we aren't logging any private information, but we see what command was executed. We're able to see how long it took that command to execute. So if you ever get into a dispute of how fast or slow something is, you're able to get a lot of information by simply upping this log severity to be able to get the query performance logged alongside everything else. Pushing just a little bit further through the configuration, we then also tell Serilog that we want to enrich our log information with additional information. Now, this additional information is simply put to the log stream. Depending on where you are putting your log entries to, you may or may not need to do additional configuration. So in this case, we say from log context, which means if we add extra metadata to the log stream, it wants to grab it out. With machine name means that we want to inject the machine name. With thread ID means we want to inject thread ID. And then with correlation ID is something specific with Serilog where they will create a unique correlation ID, a unique GUID value for each web request, which means that you can then track every log entry that is related to a single web request. Makes it really easy to be able to go through and adjust things. And then finally, we have our write to definition, which is where do we want our logs to go to? So in here, we can see we want them to go to console with no other config, which means it's going to respect all of our defaults. Our second write to is to a file, and that's where we write to our logs.mylog.txt, but we have a restricted to minimum level information. So even though we're allowing debug stuff to go to the console, I want to make sure that we only write information things to the file system. So even without using a third-party bit, right, we could create two different log files, right? We could create a log file of only errors if we wanted to by setting a write to destination with a restricted minimum level. We do then have an output template. That output template is where we control what we want to be included in that file. And that's where you can see here, for example, we have our correlation ID. Since we included it in here, this is how we get it into that log stream. So we have a declarative way of setting up our configuration, which is far more complex than the default stuff that we had from Microsoft, because this is what Microsoft gave us out of the box. The magic behind how this all works is by utilizing a logger configuration early within your application process. Now, what's included in this sample is a way to inject and configure logging before your application even starts. The reasoning behind this is if I do something crazy, say, for example, I wire up something to be resolved via dependency injection, and I don't register that item into the dependency injection container. Rather than getting the dreaded process failed to start error message, this ensures that the login system is up and running and ready to go prior to trying to actually build your application and configure dependency injection so that you can take instant actionable steps to resolve what may have been going wrong. And so to do this, it's really a fairly simple piece where we define a configuration with a new configuration builder, which is kind of mimicking what happens later on automatically with creating a host builder, where we simply say, hey, we want the configuration to consist of our base path is here, our JSON file that we want to include is app settings JSON. We want to include environment variables. We want to build our configuration. And the reason that we need to do that is that right in the beginning of our main method, we want to configure Serilog. And to do this, we say, oh, our logger, which this is a default ASP.NET logger, its configuration is the configuration from Serilog that has been read from this configuration. Because then we can do things like log.information, starting web host. That's where that starting web host message came from. Then we can make our calls to create web host builder to build and run. And by doing so, anything happens here, we can catch it in the exception. We can log that fatal with the exception details so that we know what went wrong. And then we can take action. And then down here, this is where we actually go through and build our web app, and we can tell the web app we want to use Serilog, which allows it to do some of its niceties to hook up things such as tracking some of the ASP.NET things. The last piece that we can do for a little bit of better clarity is we can enrich the logging system with things that might be of benefit to us. So for example, if we want to include the user in our logs, we can do something like this where we tell Serilog, hey, I want you to also enrich this diagnostic context or this log context with the requested user. Okay, you gotta be careful with doing this, but I wanted to be able to show as an example. You could use this, people have always asked in the past, right? Could I use this to inject the actual request ID out of an ARR or load balancer scenario? Absolutely. You can use this to inject anything that you want into that log stream. And this goes for every request. So it makes it a little bit easier for you to be able to do the kinds of things that you need to do along the way. So the idea with this is it's a simple configuration. As soon as we get through this simple configuration, then we don't have to touch it. And then we adjust our levels. We do that kind of thing. I did mention that Seek supports the idea of a variable log level. And the way that they do that is there's a couple of extra configurations here with a thing called a level switch. I provide an example here, but again, I don't want it to go crazy into the commercial side and be able to outline that. But the idea here is that it is able to control that default level from outside. There's a question here about, is correlation ID consistent between microservices? A correlation ID is only consistent within the actual running web request. So think of it as a server request gets in, that request is assigned an ID. All the way through that particular app, it's going to have that same ID until that response is completed. If you go off and each, make 3 different microservices calls, each of those will be, an individual web request. So if it's each HTTP request will have its own correlation ID is the easiest way to think about it. So I want to kind of open up for any questions that you guys may have. The idea here was this app is nothing more than the out-of-the-box app with this stuff in it. It's built in a way so that if you're using ASP.NET Core, you can use this as your example. The only thing that you have to do in addition to these code examples is include the Serilog NuGet packages, which they're all right here. These bottom 2, it appears, are no longer actually necessary to explicitly name. So it's simply Serilog ASP.NET Core, Enricher's correlation ID, and settings configuration. But you can take this, pull this demo down, you can play with it, you can adjust the levels up and down. If you ratchet Microsoft down to debug, you get crazy amounts of data. So it's kind of fun to be able to see the different kinds of things that you can get along the way. But the idea here is to make sure that we all just understand what's available, how we might be able to use it, and being able to take those logit messages that have been going on behind the scenes in our applications for years and doing something with it, since we don't get the out-of-the-box support to be able to do something. So I'll open up for questions. If anybody has any, feel free to either come off mute or put in chat, and appreciate everyone's time this evening.
Got a question, Mitchell.
Yeah.
Um, kind of related to the correlation ID consistent between microservices. Say you got an HTTP request and that ended up you made a database call and the database call blew up. Would you get uh, information like would you be able to have exception information logged with that correlation ID?
Yes. Yep. So if there was an exception that came out, any log entry that occurs in that context will have that correlation ID. So exactly, entity framework isn't able to save the query because model binding failed. That whole exception would be output with the correlation ID, so you'd be able to track it together.
Awesome, thanks.
And then there was a question in the comments here. In the finally, I have a call to log, close and flush. If instead you instantiate log in a using, will that still be called? I.e. is close and flush part of disposable? Sort of. Log and the close log and flush is a the general practice right now is to call that because it ensures with an extra bit of definition, it will make sure that any downstream sinks have been flushed out. So it's a little bit more aggressive than just a what you normally get in a try catch. The other thing is that we're going off of a static. We're not going off of an instance here. I'll bring the code back up here to make it a little bit easier to understand. But basically, in this context, log is not like my individual log item. This is log Microsoft's overall ASP.NET core login, I believe is where it comes from. So it's not something I can really do a using around because I don't have an instance. So doing the more traditional try catch finally gives us that ability to make sure that we tell the logging system, the logging infrastructure, I want you to please make sure that you get everything configured, because you'll see here, log is the serial log helper bits, and then close and flush is just that ability to, if you look at the documentation, it just goes through and does the dispose, but it really is, it is just a simple clean way. It's just a really nice way to make sure that that global logger config is cleaned up. It's only really the only time I've ever seen it be an actual, like we have to do it that way, is a failed dependency injection registration. So in other words, when the app truly just doesn't start, things can happen so fast that the file doesn't actually get written out yet because there's some performance things in there. And that was it's just a method call suggested to be able to flush things properly. All right. Well, I really appreciate everyone's time this evening, and I'll hand things back over to the organizer.